Robert, you mentioned the importance of keeping variables private. But so many programmers just add getters and setters. Why is that a problem?
Well, Andrew, it's a common pitfall. You sacrifice flexibility.
Flexibility?
Yeah. Imagine you decide to change the type of a variable. Suddenly, every place that uses a getter or setter has to be updated. It's a maintenance nightmare.
I see. So, what's a better way?
Think about immutability. Avoid modifying the object itself. Return a new object with the updated values. Much cleaner.
But isn't that just more code?
Slight pause. Not necessarily. It's often more concise in the long run. Think of it like building with Lego bricks. You build from smaller interchangeable components. That reduces errors and updates.
I see what you mean. Can you give an example?
Sure. In a banking app, suppose your user's balance is stored as an integer. If you later decide to store it as a decimal, you'd need to change all of the setters and getters calling this.
Whoa, that's a huge update.
Precisely.
So, are there any exceptions? When might getters/setters be appropriate?
You know, sometimes you need a calculated property that isn't just a simple data retrieval. But even then, try to avoid unnecessary complexity.
So, you're saying less is often more.
Absolutely. Focus on simple, well-defined objects, and you'll avoid these problems.
Okay, that's really helpful. Thanks, Robert. Hey, Robert, thanks for joining us. We're diving into clean code today. You mentioned the importance of abstracting data. Can you give us a concrete example? Maybe something we can all relate to?
Sure. Imagine tracking the temperature of a room. We could represent it concretely as a simple temperature in Celsius.
Okay, so we have a variable temperature Celsius.
But what if we want to display that in Fahrenheit? Or potentially later work with Kelvin? The concrete implementation is now tied to a single unit. This makes it inflexible.
So, a cleaner approach would use an abstract representation?
Exactly. We could define an abstract temperature that exposes methods to retrieve the temperature in any desired unit. This isolates the implementation of temperature conversion from the consumer.
That makes sense. But if we go too abstract, could it become overly complex?
Not necessarily. We just need to focus on the essential methods that the consumer needs to interact with, the essence. The user doesn't need to know the internal conversion formulas.
So, what's the guideline for determining this essence?
It's about understanding the purpose and how the data will be used. What are the core manipulations that the users need to do with this data? You'd want to abstract in those essential actions.
So we wouldn't necessarily abstract away every possible detail, just the irrelevant ones, right?
Precisely. You focus on the essentials. In our temperature example, we wouldn't hide temperature entirely, we'd hide the conversion implementation, not the value.
Insightful. This seems important for maintainability, too.
Absolutely. Imagine you decide to use a different internal representation later. The consumer's code remains largely untouched.
Makes perfect sense. So, sometimes the simpler concrete approach is better, right?
Absolutely. If performance is the priority, and you're not expecting the internal representation to change. But in many cases, the abstract approach offers greater flexibility.
This is really helpful, Robert. Thanks for shedding light on this.
My pleasure, Andrew.
Hey, Robert, we're diving into clean code today. What's the deal with this law of Demeter? I've seen some code that looks like a train wreck of calls, and it's hard to follow.
Right, Andrew. The law of Demeter, in a nutshell, says that a method should only interact with objects it's directly responsible for. Avoid these long chains of calls like ctxt getOptions, getScratchDR.
So, why is that a problem? Just seems like a lot of nested calls.
It's about encapsulation and modularity. The calling method knows too much about the internal structure of ctxt, options, and scratchdr. It's tightly coupled. Imagine a train with lots of cars linked together. Problems in one car can affect all the others.
But what's the alternative? Seems a little pedantic, don't you think?
Well, you want to keep functions focused and maintainable. You can use accessor methods, like ctxt getOptions, ops getScratchDR, for modularity and reduce the impact of changes.
Can you show me an example of that, and how it makes it easier to follow?
Sure. We'll move the code to a more manageable format, Options ops equals ctxt get options. File scratch dr equals ops get scratch dr. Final string output dr equals scratch dr absolute path. This reduces the complexity and improves the code readability.
Got it. So, what if the objects are just data structures like plain containers?
Then the rule doesn't apply directly. The key is hidden state. If objects have methods, then demeter matters. If not, likely just fine.
Okay, but what if there are access or method for data structures? Are these still bad?
In some frameworks and standards, data structures do have accessor methods. It depends on the specific framework.
Interesting. So, is it always about hiding internal data?
Not always. Sometimes, you might want a more direct approach based on maintainability.
Right. So, like a balance between maintainability and direct access. Makes sense.
Exactly. Demeter is often about maintaining flexibility and reducing ripple effects when making changes. It's about cleaner, more maintainable code.
Thanks, Robert. That makes sense now. Robert, we've been talking about object-oriented design, and you've highlighted the importance of clear boundaries within classes. But what happens when, a function starts messing with data that doesn't belong to it?
Exactly. That's a recipe for trouble. A hybrid structure tries to be both an object and a data structure.
And you mentioned feature envy. Can you give us a real-world example?
Sure. Imagine a class for a bank account, but it has a function to calculate taxes on transactions. That's a function that really belongs somewhere else, not in the account class.
So it's doing things it shouldn't be doing?
Yeah, it's trying to do too much. These hybrids often have functions that manipulate data, and public variables or accessors/mutators which treat the data like a global variable instead of a member.
So, how do you avoid them?
Design with clear separation of concerns. Functions should be focused and operate only on data that's directly related to them.
How about when you have a large project, with existing code that needs to get updated?
Then it's an opportunity for refactoring. We break down the tasks into more narrowly defined functions/methods for each object, and we make the data private and accessible through appropriate accessor/mutator methods.
So, sometimes a hybrid structure might just be a better fit?
Well, no, not necessarily. Usually, it's a sign of a design that needs cleaning.
That makes sense. So refactoring is key. Thanks, Robert.
It's a process of creating cleaner, more focused designs. It's a journey. It's about knowing what belongs where, and in those moments, separating concerns.
So that's the key takeaway. Avoid mixing data structures and objects.
Exactly. And that's what avoids this feature envy situation.
Makes perfect sense. Thanks. Okay, Robert, let's dive into this hiding structure idea. You've mentioned encapsulation and the law of Demeter. Can you give us a real-world analogy for how this applies to our code?
Sure, Andrew. Imagine a car. You don't need to know how the engine works to drive it. You just use the steering wheel, gas pedal, etc. The car's internal workings are hidden from you. Our objects should be similar.
So CTXT is like the car in this example, right? Instead of directly accessing its scratch directory, we should use methods?
Exactly. Instead of ctxt get absolute path of scratch directory option, we should have a method like ctxt create scratch file stream, class file name. It's cleaner and more maintainable.
But wouldn't that be slower? Direct access might be faster?
Well, in most cases the performance difference is negligible. Maintaining readability and reducing bugs is far more important.
I see. So, that's the core idea. You're saying that instead of accessing internal data, we should interact with the object through methods it exposes.
Exactly. And you should design these methods well to do specific tasks, as opposed to opening up the object to other functions.
What if there's a specific case where you need the absolute path directly?
We should consider whether that specific case is frequent enough to warrant an exception to the rule. Perhaps a specialized helper function outside of ctxt is better than altering ctxt's responsibilities.
Interesting. It sounds like you're suggesting a design pattern where the object itself handles the creation of the file. Makes a lot of sense.
Exactly. Keeps the code more focused and less tangled.
Great example, Robert. Thanks for helping me understand this. Robert, you've talked a lot about writing clean code. But what's the deal with objects versus data structures? When should you pick one over the other?
Well, Andrew, it's a bit like choosing a toolbox. Objects expose behavior and hide data, making it easy to add new types of things. Imagine a car. You add a new engine, a new model, but the way you drive it remains the same.
So it's flexible for new kinds of things?
Exactly. But adding new ways of driving, like a new automatic transmission, is harder. Data structures, on the other hand, are more about the data itself. Easy to add new behaviors to existing data, but creating a new, completely different data structure is tough.
So, a spreadsheet is more like a data structure then?
Exactly. You can easily add calculations or sort data, but changing the core structure of the spreadsheet, making it handle a database structure, that's harder.
Okay, so it's all about flexibility, right?
Exactly. It comes down to what you want to add in the future. If you need lots of different kinds of objects, then objects win. If you need to add lots of new behaviors, then data structures are better. You need to know what you're trying to build.
But what if you need both? Like,
A hybrid approach is often the best answer. Combine features of both to cater to specific needs.
you mean sort of like a mix and match?
Yeah, a mix and match approach is usually the most maintainable solution. Clean code is about making the right choice for the job, not a rigid structure.
Makes sense. Thanks for breaking that down.
You're welcome, Andrew.